This lesson is about electron dot notation, orbital notation, and electron configurations. It's actually going through and grading homework, but giving you a chance to see how all this is done once again. Okay, so homework from 2 days ago, we didn't grade it yesterday because of the lab, is write orbital notation, electron configuration, and kernel electron configuration for copper and ruthenium. So to do that, you need a periodic table. And copper is located right here. Okay, and so the first thing you're going to do for the orbital notation and the electron, both kinds of electron configurations, is to write the atomic symbol. Okay, you have to have the atomic symbol followed by a colon. Okay, it says we're starting with hydrogen and helium has to be moved over here because helium is actually part of the S sublevel region. And so we just move it over here to keep it part of this S sublevel region here. Then we've got, let's see, for orbital notation, we're going to have 2 electrons there for hydrogen and helium. And this is primary level 1, sublevel S, 2 electrons. And then we're going to get to lithium, and there is the second primary level and some S electrons. So there's our orbital, there's 2s, and there's our 2 electrons. Then we're going to be over here where boron is, boron through neon, that's the P sublevel region, and we're still in the second row of the periodic table. Second row, so that's the second primary level. So we have 2p, and we need 3 boxes for the P sublevel to accommodate those 6 elements and the 6 corresponding electrons. And you put them in 1 box at a time, and then pair it up where you need to. Okay? And the next row works the same way. We're going to go through this entire row, but for 3. So this is 3s and 3p. One electron in a box, and come back and pair them up. And now we're at 4s. And we're at 4s, we're going to fill up the electrons that correspond to the position of, it's not the same thing as these atoms, but it corresponds to the position of these atoms, or these elements, potassium and calcium. So that's 4s. We're going to have 2 electrons there. And when we get to this section here, that's the D sublevel region, and that's in the 3rd primary energy level. Okay, we're going to drop back 1 level to fill up the D sublevel. So that's 3D. There are 10 elements there corresponding to 10 electrons, so we need 5 orbitals for that. Okay, and you're going to put 1 electron in each box and then come back and pair them up as needed. But for copper, we need 9. So we're just going to count it up here. 1 in each box. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the orbital notation that I expect you to have. Okay? Now, one of the reasons I picked copper here is to show you something that you don't have to know for this class, but to warn you about it because it may come up in college. The filling order, the way that the orbital notation is arranged for copper and for the electron configurations as well for copper, doesn't really follow this pattern exactly. Okay? I'm not going to expect you to do it in here, but I want you to know in college, for 5 elements in the transition elements area, transition metals area, there is an exception where you take an electron from 4s and actually put it down here to 3d. So copper really, in truth, has 1 electron here in a full 3d sublevel. Okay? Got it? That also happens for chromium, molybdenum, silver, and gold. Okay? But we're not going to worry about it in here. Got it? Actually happens for, probably happens for gentium, but it doesn't stick around very long enough for us to really know what's going on with that. That's a man-made element. It's around for a very tiny fraction of a second. We don't know. Okay? All right. Let's see how we're going to grade this. Got to have an element symbol. Got to have a colon. Got to have this orbital and the proper label 1s, this orbital and proper label, these 3 orbitals and the proper label, this orbital label, these 3 orbitals, this label, orbital, label, orbitals, properly filled with the right number of electrons in each one. Okay? And that comes out to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 points for this. Okay, for just that one right there. All right? Then we also had to do the electron configurations, both kinds of electron configurations. And once you do the orbital notation, that should be fairly easy. All we're going to do is count the electrons in each each sublevel, and then make that a superscript. So for 1s with 2 electrons, that's 1s2. And for the 2s, we have 2s2, and then 2p6, 3s2, 3p6, 4s2, 3d9. And in reality, it should be 4s1 and 3d10, but we're not going to worry about that in here. Okay? And let's see. A point and a point for the element symbol and the colon. Let's go ahead and give a point for all of that. Any part of that wrong right there, you just count the point off. Okay? You don't count it. So 1, 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 points. All right. Now the abbreviated version, called the kernel, K-E-R-N-A-L version, is going to remove from this orbital electron configuration the next lowest noble gas. And so here's copper, and it's 29. If we count our way backwards, when we come to argon, that's our next. Here's copper. Count our way backwards. Here's argon, and that's the next lowest noble gas. So we're going to remove argon's orbital notation or electron configuration from this, and argon finishes right there. It's 1s2 to 3p6. So we're going to write Cu colon, and we're going to replace all of that with just the element symbol for argon in brackets. Has to be in brackets. And then you just finish it out. 4s2, 3d9. Okay? So that's going to be worth 1, 2. I'm going to give a point for the brackets and a point for the symbol, okay? And then these 2 points here. So 1, 2, 3, 4, 5, 6. 6 points for this. Because it's the next lowest noble gas. Yes, it has to be the next lowest noble gas. You have to go from here, and this is 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19. Ding, 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 ding. There's a noble gas. That makes sense? That's all you got to do. Just find the next lowest noble gas. Plug it in and take out the corresponding electron configuration for that noble gas. And that's always going to finish at a P6. All right? Because you're going to fill up the S and P sublevels for that noble gas's highest energy level. Okay, which will be one level below whatever the element is you're working with. Since we're working with 4s, we're going to finish up the noble gas with 3s2 and 3p6. So you kind of, if you look, you can tell right away that's where the noble gas ends, and that's what I want to replace. That makes sense? Still kind of a little fuzzy on it? Okay, well, we got 2 more to do, so hopefully we're going to get you kind of straightened out. And if you don't do well on this homework, if you do the homework on time and you just make a poor grade, you can email me and ask for a makeup homework. Okay? Tell me what the homework, exactly what homework you're asking for, and I'll send you a makeup, and you can turn that in, and that'll replace the entire grade. Okay? That makes sense? Hey. So we're checking homework. If you have it, you need to give it to me. Okay. All right, so the other one we're doing here is ruthenium. Okay, so ruthenium is right here. All right, it's number 44. Now this is, it might be helpful for you guys if you were to write your orbital notations with your paper turned sideways so you can fit it all in there. If you're having trouble fitting it all on one line, turn it sideways. It's a little bit easier than writing it on 2 lines, but you can write it on 2 lines. I'm going to kind of squeeze it in here a little bit, all right, just to get it on one page. All right, so this is ruthenium, Ru. Okay, and we got all this same stuff here. We're building. Every time we add a new element, we're building on the previous element. Okay? Okay, so we're in. This is row number 1, 2, 3, 4, 5. There's where ruthenium is. Okay, and so we're in the primary level 5 here. But when we get to the D sublevel region, this region right here, we're dropping back 1 level. So this is 4D. Okay, and so everything gets filled up until we get to 4D. Oh, I left out 4P, didn't I? Thank you. I know it. Man. Okay. Now let's see. Ruthenium in the D sublevel region is 1, 2, 3, 4, 5, 6. So I need 6 electrons there. Hey.
How about your key again? I'm sorry.
Room key?
Well, yeah, because it'll get in my workroom in the room, but the...
All right. So there's your orbital notation for ruthenium. 1, 2, symbol, element symbol, and colon. Let me just remind you guys, your element symbols have to be clearly capital letters, and if there's a second letter, clearly a lowercase letter. If this U looks like it's anywhere close to being the same size as that R, it's wrong. Okay, you just got to know, you got to get that right. Okay, make sure your capital and lowercase letters look like capital and lowercase letters. All right, so there was no confusion about what you're talking about. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, total of 35 points for this. All right, then for the electron configuration, element symbol and colon, and we just count the electrons that are in each sublevel. So this is 1s and 2 electrons, so it's 1s superscript 2, 2s superscript 2, 2p superscript 6 for all those electrons, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d, 1, 2, 3, 4, 5, 6, 46. Okay? 1, 2, element symbol and colon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points. All right? Then the kernel, K-E-R-N-A-L, kernel version, or shorthand or abbreviated version, just takes out the next lowest noble gas. The next lowest noble gas below ruthenium is krypton. Okay? Ruthenium is 45, and you count your way back, you hit krypton. And krypton is going to start at this is the highest primary level, 4. That's the valence level. Then we're going to look for, let's see here. I'm sorry. 5s is the highest energy. 5 is the highest energy level. So we're going to look for the next lowest S and P sublevel. So that's going to end up where krypton's. That's krypton's electron configuration there. Does that make sense? Yep. All right. So all we have to do is write down krypton in brackets and finish it out here with those. So use the element symbol, colon, and we've got krypton, and then 5s2 and 4d6. One, two, a point for the colon, 3, symbol is 4, 1, 2, 3, 4, 5, and 6, 6 points. All right. Okay, let's see here. We've got 6 and 12 is 18. I might need to add this up on calculator. I might get it wrong if I try to do it in my head. So let's see, 6 plus 12 plus 35 plus 6 plus 9 plus 24. I got 92 points. Is that what you got? Good. So this is going to be worth a total of 92 points total for this homework problem from 2 days ago. Okay? All right, so let's look at then the homework that was assigned yesterday, and I think I just gave you one element, yes? I gave you 2? Oh, germanium and zirconium. Okay, gotcha. All right, so let's do this on a separate sheet of paper. I don't want to run out of space. Besides, I want to turn this one sideways like I talked about doing earlier. Okay. All right, so germanium, GE. Okay. Here's germanium. Okay. And so we're going to have 1s, 2s, 2p. Do I need to give you guys a minute to finish grading that first one? Y'all got it all taken care of? Okay. 2p, there's 3 orbitals in 2p. 3s. 3p. Thank you. There's 3p. Then 4s. And after 4s, the fourth, 1, 2, 3, fourth row, we're going to get into the 3D sublevel. 3D, and there are 10 orbitals. 10 electrons, 5 orbitals. I always seem to get this question over and over. Why do you write the boxes if there are no electrons? Okay, it's just like when you leave your house. The house doesn't disappear. It's still there. The orbitals are there, even if there are no electrons in there. Okay, so germanium then goes into 4p over here, and we got 3 boxes there. So 1, 2, 1 in each box. Come back and pair them up. Fill up 3D. And we need 2 more electrons here. Okay, when we get into this P sublevel region, this is 4P, we need 2 electrons here for gallium and germanium. And we stop. So there's an empty box there. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 points. And then we want the full electron configuration. One S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P2. Okay? Element symbol colon. That's 2, 3, 4, 5, 6, 7, 8, 9, 10 points for this. And then we want the shorthand version, or the kernel version. So the next lowest noble gas from germanium is argon again. Okay? We're going to put argon in brackets. And then argon's orbital or electron configuration is going to end at, this is the highest energy level, 4. The next lowest energy level is 3. And when you have the S and P sublevels full, that's the noble gas. So all of this is argon. We're going to finish out just this part here. 4S2, 3D10, 4P2. Okay? Element symbol colon, that's 2. Brackets is 3. Symbol is 4. 5, 6, 7. Now, in addition to this stuff, this homework problem also asks you to do the electron dot formula. Okay? And so all we have to do is count up the number of electrons in the highest primary energy level. The highest level is 4. It does not include 3. So there's 2 electrons here, 2 electrons here. Together, 4s and 4p make up this valence level. So that's 4 electrons in the valence level. So we're going to write germanium, 1, 2, 3, 4 dots. Okay? So this is the electron dot formula. You can get a point for the element symbol and a point for each of these dots in the correct places. Okay, so that's 5 points for this. All right? All right then. Let's go to zirconium. Where's my periodic table? Okay, here's zirconium. Okay? And so this is going to be in the 1, 2, 3, 4, 5th row. Okay? ZR colon, 1s, 2s, 2p, 3s, 3p, 4s, 3d, because you're going to drop back one level. Here's 4. We're going to drop back to 3 when we get to the d sublevels. 1. You need 5 orbitals in d. 1, 2, 3, 4, 5. I don't know if you guys have noticed or not, but each time you go up a primary energy level, a sublevel, you add 2 orbitals to it. So S sublevels have 1 orbital. Okay? P sublevels have 3. D sublevels have 5. F sublevels have 7. You don't have to do F sublevels in here, but that's just how it works, okay? So 3D, then we go to 4P to finish out that row. Once you finish out 3D here, this is D. Then we're in the P sublevel region, and this is the 4th primary level, okay? So this drop back a level, we go back up to the primary level here. So this is 4p, 3 orbitals, 5s, s sublevels always have just 1 orbital, and zirconium is going to be in the 4d sublevel. So this is 5s, then 4d, drop back 1 primary level. And we got 5 boxes for 5 orbitals to accommodate 10 electrons, 1, 2, 3, 4, 5. Okay, 1 in each box. Come back and pair them up. You know what's sad? Is I keep repeating this over and over every time I do it, and somebody's going to get it wrong on the test. Despite my repeating it over and over. That's just sad. I'm sorry. I'm hoping, though, by emphasizing this, that fewer people get it wrong on the test. They realize 1 in each box and come back and pair it up. 1 in each box, come back and pair it up. All right, so zirconium has 2 electrons in 4D, 1 in each box. Boom, we're done. Got that? Don't put those 2 electrons in the same box. Okay? So I'm not trying to make anybody feel sad, but I am trying to emphasize it. So hopefully, nobody's going to make that mistake on the test. Okay? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Yes, those empty boxes count points. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 points for this part of the problem. Okay? And then we want the electron configuration, the full electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d2. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points. Alright, then we're going to get to the shorthand version. The next lowest noble gas below zirconium is, move it over a bit so you can see, krypton. Whoop, still can't see it. Here's zirconium, there's krypton, and it's going to end at the next lowest primary energy level, which is here, P. 5 is the highest energy level. Here's P, 4P. So that's where krypton is going to end right there. This is the electron configuration, sorry, for krypton. Okay, stops right there. And so all we have to do is put this part on the end. No, sometimes it can be up to 4 n numbers if you're getting into the S sublevel. We don't do that in this class, but since we do get into the D sublevel, sometimes you can have 3 n numbers. So the question was, it always the last 2 n numbers, but that's not true. So 1, 2, brackets is 3, symbol is 4, 5, 6, 6 points. Okay, and then we got to have the orbital notation. I'm sorry, electron dot formula. So zirconium, and there's only 2 electrons in the highest energy level. 1, 2. Okay, so that's a point for the symbol and a point each for those dots being correctly written. Now those dots can be on any 2 of the 4 sides, but you can't put the dots side by side. Okay, if they're side by side, they're just both wrong. All right, they only get 1 point for it. So zirconium, the dots can be here and here, but they have to be on 2 of the 4 sides. Okay, so that's 3 points for that. All right, let's add it up. No, yeah, we got it all. That's it.
Why don't we just add more dots?
Count off for the extra dots. So if they had 3 points, they put 2 extra dots. Count off 2 points to get 1 point. Count that whole thing wrong. The question was, what if they had 6 dots around zirconium? Count the whole thing wrong. Okay. All right, let's see here. We got 28 plus 10 plus 7 plus 5 plus 36 plus 12 plus 6 plus 3. I got 107 points. Did anybody else count it up? Check me. 107 points. Okay. Any questions? Now, you notice that you get the most points for the orbital notation, right? I hope you notice that. Here's the point. If you get the orbital notation right, my experience has been people tend to get the other stuff right. Okay, now that's not always true for the electron dots, as Will was talking about. Sometimes people I've seen people, if I give them zirconium as the element to draw the electron dot notation for, I've seen them put 40 dots around it on a test. Please don't do that. It's 2 dots, okay? You can maximum of 8, at least at this point in time, maximum of 8 dots, okay? There's actually a time later on when it might, we won't get to it in this class, but there are times when you can have more electrons than just that, but we're not going to do that in here. Just those 2 dots that are in the highest primary energy level, or whatever number there are in the highest primary energy level. Only in the highest primary level and the S and P sublevels should be the places you get those dots from. If you've done everything right, you cannot have more than 8 dots around an element symbol for the electron dot notation, because the S sublevel can only have 2 dots, 2 electrons, and the P sublevel can have a maximum of 6 dots, and you add those up, you get 8. Okay, and that's called the Octet Rule. Okay, and that's, if you remember that from physical science, if you were taught the Octet Rule in physical science, that elements tend to want to get to 8 electrons in their highest energy level, that's why. Okay, well, that's part of it. There's actually more to it than that, but that's part of the reason. All right, so let's see. This class has gallium, which is Ga. Can I have your attention up here, please? All right. In fact, I tell you what, let's do. Let's turn this sideways, like I stated earlier. We'll turn this sideways and do it this way because that gives us some more space. Okay. So gallium is right here, and it's in the 3rd row, and in the the 4th row of the periodic table, and it's in the P sublevel region over here. Just close. So let's see, we got 1s, 2s, 2p, 3s, 3p, 4s. Then you drop back 1 when you get into the D sublevel region. And there's 5 orbitals there. That's 3d. And so we're almost to gallium. Right now we have all the orbitals we need for zinc. I haven't put the electrons in there. But gallium is going to be in the 4p section. And P sublevels have 3 orbitals. So you need 2 electrons here and 2 here. You put 1 in each of the orbitals here and come back and pair them up. 2 here, 1 in each, come back and pair it up. Okay, and that's the orbital notation for gallium. 1 point for the symbol, 1 point for the colon, 1 for each of these boxes that are correctly filled in. So that's 5 so far, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Then the symbols down here, 1s, that's 21, 22, 23, 24, 25, 26, 27, and 28 points for this. So then we want to do the full electron configuration. Let's see, this is the assignment where we do all of them, right? Okay. So we have gallium as the symbol. Electron configuration, that is not that. Sorry. Forget that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. Then the abbreviated version, called the kernel, K-E-R-N-A-L version, or shorthand version it's called sometimes, just takes out the noble gas, the next lowest noble gas, and replaces it with the symbol for the noble gas in brackets. So if we look at where gallium is on the periodic table, it's right here, and the next lowest noble gas is argon. Argon's electron configuration ends at 3p6. The highest energy level is 4. That's gallium. And so the next lowest noble gas is going to end wherever the next lowest primary level is in P6. So all of that's going to be replaced with the symbol for gallium. For the symbol for argon.
I have a question.
Okay. And then we're going to finish that 4s2, 3d10, 4p1. What's your question?
Can you go back to that chart?
The periodic table? You want to go back to the periodic table?
Can you just put it back on the thing? Okay, so you see how you went from gallium to the arsenic? You're just going a step above, like you're going across.
That's one way to think about it. I'd say this is number 31. If I keep counting back in numbers until I come to a noble gas, I come to argon. That's a noble gas.
Okay, boom. So you just, now how did you figure? Oh, you can take away. You can take away now. So how did you figure out that you were going to start at 4s3, then go up to 3d?
Because argon's electron configuration stops here. We're replacing all of the electron configuration that is galliums. The part that is the noble gas gets replaced with just the symbol in brackets.
But when you say electron configuration, does that mean the argon is number 18? Does that mean?
Yes.
Oh, so it stops at those numbers. All those numbers equal 18.
Yeah, if you add it up, 2, 4, 10, 12, and 12 and 6 is 18. So 18 is right there. That's the atomic number for argon, so that's one way to think about it. That's one way to figure it out. Okay? All right. Let's add up the points we got so far. 1, 2, 3, 4. I'm sorry, not 4 there. 4, 5, 6, 7, 8, 9, 10, 11, 12 for the brackets, 13, 14, 15, 16. So, well, let's see. What did I say this was? So this would be 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points for this part. 6 points for this part. And then you had to do the electron dot formula. And so all we have to do for the electron dot formula is count the electrons in the highest energy level. Yes, 2 in 4s, 1 in 4p. 4 is the highest primary energy level, so all those electrons make up the highest energy level. 1, 2, 3, so Ga, 1, 2, 3. So let's see, I'm going to give you a point for each of the dots. Now look, the dots have to be on 3 of the 4 sides, okay, and the symbol too. So that's a total of 4 points. Yes? You know what? You're right. There is a point for the colon. 7 points. Okay? 7 points. Okay. What's your question? One, 2, 3. 1, 2, 3. 1, 2, 3. That's how I got the 3 dots. All the electrons in the highest primary energy level.